Hi, this video is going to kind of help you sketch your original function from the graph of derivative. So first of all, you need to have a fair idea about what exactly does the derivative graph represent. So suppose if I have a graph out here. Alright, so this is your dy by dx on y-axis, and you have x values out here. And suppose if the curve looked like something like this. So of course this is your derivative function, not your original function. Now what I have to do is I have to kind of sketch the derivative from here. The first and most important thing is that we need to understand the significance of derivative. So what exactly does the derivative graph, what are the conclusions that we can draw from the derivative graph? So the first conclusion that I can draw is wherever your dy by dx is 0 can be max or min, or maybe point of inflection, stationary point of inflection. If this case is like almost like some cases it comes. But what I have is, if I look at the derivative graph, I can easily figure out from maxima or minima. So consider that if you have a function which has a turning point, which has a maxima. So suppose if out here we have, let's say this is a minima. So this is the function y and this is x. So this side, if you look, this is the slope is negative and this side slope is positive. So if I take a tangent and put it like this, the slope this side is going to be negative and slope this side is going to be positive. Okay, so now if you look at this, this is your derivative value. Like, wherever your derivative is 0, this can be maximum or minimum. How do I recognize that? So if you look at the graph, if your slope is changing from negative to positive, it means that this is a turning point that can be minimum. So now out here, if you look at this, my slope is changing from negative value, because if you look below, above this is positive and below this is negative. So here the slope is negative and here this slope is positive. So this can be then a possible point of minima. And this can be possible maximum. Now what I do is I also look at some of the very critical points, such as the point of inflection. So now wherever your derivative has a minimum or maximum, you will have a point of inflection at that point. Because if you know that for point of inflection, your double derivative equals to 0. Right? So double derivative is 0. So if you look at this point, because if I draw a tangent out here, it's going to have a slope of 0. So this is a simple example that this is going to have a point of inflection. Now let us talk about how do we go to the final stage. So if I have to visualize, this is a maximum. This might be a point of inflection where the concavity will change, and this side you have a minima. Now it will be always better to kind of sketch your double derivative graph before you sketch the function. So what I do is I sketch the graph of first double derivative. Now to sketch double derivative, slope of single derivative will be double derivative. So if you look at the slope, look at the slope. So what is happening is, from a very high negative slope, it's coming close to 0. And here is the 0 point, and then from 0 slope it's becoming more and more positive slope, and then it's increasing. So what I'm going to do is, first I'm going to sketch the double derivative. Alright, so double derivative graph, if you look, the slope is negative, so it's now on y-axis I'm trying to plot double derivative. So slope is going to be negative. Here we got the slope of the single derivative, and here we go with the positive side. So this is going to give you a clear picture. So this is a point where you have single derivative 0, and you can see double derivative. This is the graph of double derivative, right? Your double derivative graph is going to have a negative value, because if you look at that dotted points, your double derivative will be negative, and here at this point your double derivative is going to be positive. Now what I do is I try to now figure out two things, that this is a maximum, this is a minimum, this is a point of inflection, because even you look at the double derivative sign diagram, if you look at the double derivative value, it's changing from negative to positive. It means that this is 100% the point of inflection. Okay, so now let's draw the original graph. How can we draw? Okay, so first of all, here the slope is positive, it's changing from positive to negative, means, and it's a maxima. So your curve will be something like this, a maxima. Then there is a point of inflection at this point, so maybe concavity. Here it's concave down, till here it is concave down, and after this it is concave up, and then attains a minima, and then here we go. So this is how the curve look. Okay, so this is my double derivative, this is the original function that is gonna look like. So if we understand in simple language, look at this. Derivative 0, double derivative negative means a maxima. Derivative 0, double derivative negative, let us talk about it. Derivative 0 and double derivative negative for maxima. So this is 100% correct. Slope positive, till here you can see the derivatives lying above x-axis, which means positive slope, clearly confirms our results, and you can verify at the other points as well. Hope this video helped you understand this, and I'm going to put another sum for this now, so you can check that sum as well after this.